let's draw a picture out for this problem. So first, it's nice to know what angle I'm looking at. So I'm given an angle theta, and it's between pi over 2 and pi. So I don't know, it's somewhere in here. Let's try that again with a straight edge. So here's our angle, and this is theta. So notice that we fall over here in quadrant 2. Now if you take an angle that's in quadrant 2, and we want to look at doubling that angle, which quadrant are we going to fall in? So let's take a look at that. If your angle is between pi over 2 and pi, so I'm literally going to use what's written up above here in blue. So I'm going to say like this. So I know that theta is between these values. Now if I just multiply everything by 2, I know that my twice the angle has to fall between pi, so over here, and 2 pi. So this angle, when doubled, is either going to fall, so if it's exactly 90 degrees, okay, so if it was exactly 90 degrees, it would fall right over here. And if exactly pi, it would fall at 2 pi. So it's going to be somewhere down in these two quadrants. So let's take a look at the sine of twice the angle. Well, the sine of twice the angle, sine is negative here, and sine is negative here. So my answer should come out to be negative. What do we need to know about this triangle over here? Well, let's construct our triangle. And we know that for that angle theta, it has a cosine value of negative 5 over 13, which means that this length down here is negative 5. This length here is 13. Finishing out that triangle, we end up with the adjacent side being the negative 5, so we'll square that. Plus, we don't know what this side is called. We'll call it y. Well, we shouldn't say that we don't know what it's called. We called it y. We don't know what its value is. So we have to solve this. So we're getting plus or minus 12. We know that this is going to be the positive 12 because we're headed upwards since we're in quadrant 2. And that will make sine positive. So what do we have from this picture? So for theta, we know the following. We know the cosine of theta is equal to negative 5/13. The sine of theta is equal to 12/13. And now the tangent is equal to 12 over negative 5. So we're going to use this information here. Let's go back over here. Well, the sine of 2 theta is equal to 2 sine theta cosine theta. So that's equal to 2 times our sine theta is 12 over 13. And our cosine theta is negative 5 over 13. So my denominator is going to be 160, let's see here, 169. Our numerator is going to be 120, because 2 times 5 is 10, times 12 is 120. And this is going to be negative. Here's a couple things you should notice. First, this value is negative, like we said it would be, because sine is negative in either of those two quadrants. Second thing you should notice is that this value, 120 over 169, okay, is less than 1. So that's also important. If I would have come up with the numerator more than the denominator, we would have had a problem there. Okay, because you can't have sine or cosine values more than 1. So that's that problem. Okay, let's do the next one. So we want to calculate the cosine of 2 theta. Well, we've got 3 different formulas to use for that. All of them, in this case, are going to be easy. So I'll use cosine squared minus sine squared. So we know cosine of the angle is negative 5 over 13 squared minus the sine of the angle is 12 over 13 squared. So this is going to give me 25 over 169 minus 144 over 169. And if we do that subtraction there, I believe we get 119 over 169. Let's just grab the calculator and check just to make sure our numbers are working out right. Okay. And of course that is a negative value. So let's see if we can actually figure out what this angle is. If we ask the calculator to tell us what angle theta is, we could use what's called the arc cosine, or the inverse cosine. So let's see if that's here. It's got modular arithmetic. You'd think it'd have the arc. Oh, there we go. Just push the inverse button. So, we don't know what our angle is, but we do know if we take the arc cosine. I guess I'm going to have to plug it in first. Negative 5 over 12. Okay. So now I'm going to do the inverse cosine of that guy. And I'm going to get an angle of 114.6 degrees. So this is kind of a check that you can use. Okay. If you double that angle, you get 229.25. Okay, so here's the double of the angle. Now if I take the cosine of that double angle, so 229.25, and now I take the cosine of that guy, I get negative 0.65. And that should be the same number that I got the original way. So let's just check. We're going to take 119 and divide it by 169. Okay. And we're getting a value it's in the ballpark there. Of course, this value's got to be negative. Let's go back and just check to see if we can make this any more accurate, or if maybe there was an error in the computation, because those just feel a little bit far away than I'm comfortable with. So we have negative 5 over 13. I'm wondering if I put a 12 down there when I did this. Our cosine gives me 112. Oh, there it is. Okay. So 112.61. So I bet you that's going to make a difference. So let's do this. 112.61. So do you see how by checking it, and I didn't do that on purpose, okay, but by checking it, I was able to catch my mistake. So just verifying whether these answers are right or not. So 225.22. Okay, so let's try that guy again. So we want to know what 119 divided by 169 is. Okay, and we get 0.7 roughly. And if we take 225.22 and we take the cosine of it, we also get that 0.7. Now notice that these are both negative because of this, but it does work out.